and you come back from your jog and you go, hey, how many core files did I get? You know, and you saw in the beginning, like Chris said, finger on screen was the first test. That's typically what you have to do for a lot of stuff if you can't get to the back end. So Palm.
You guys ran it on the physical phone itself rather than the VirtualBox emulator?
Yeah. Python on the phone.
Okay, so your phone was just like sitting on the table, just crunching away.
I kid you not. Like you just go out to get a drink or something, you know, food or something, and come back and you just check your core file, log back in your box. It's great. Although the emulator was definitely handy. The emulator was we found some nice things with the emulator too, because you can do some things with the emulator you can't do with the actual phone. So we talked about results. We found a bunch of stuff. So we can walk through some of these. So you saw the URL handling crash where I literally would click something and it would crash. Well, we found like 3 or 4 of those. Some floating point exceptions in the browsers. If it was in portrait mode, you could get it to crash. We had one bug. So Palm fixed the URL handling crash, and then within 24 hours, I had 2 more memory corruptions because they still couldn't parse URLs right. So we ended up going back to them and being like, listen, you fixed it for this length, but you missed this and this because you parsed wrong. And then they ended up fixing that again. So we did find some interesting stuff. A new thing that was found was the doc viewer crash. One thing you'll note here is this is a pretty cool crash in the sense that those are R41s, so you can kind of see how memory corruption and remote exploitation is possible. That really drives us right into the next thing. So now that we have crashes and we have bugs, we had set out a goal initially is to figure out the device, figure out how it works, find as many bugs along the way, get it patched, because if this was going to be my personal phone, I want things patched. I don't want to spend 6 months trying to figure out root cause on something specific and then find out I can't do that because NX is handled differently or something like that. So we really thought that there was another way to go with this, and it turns out with a lot of the injection capabilities of web application testing, that was really the way to go to make this much easier. So we don't need memory corruption to steal things off your phone. We can do that through some other very interesting ways. And that's what we're going to roll right into is the injection. So it's cool we found memory corruption. We can probably make a crash. We could probably have kept going with our test results and found a whole bunch of other crashes. But we wanted to really investigate the web application side of this phone. And that's where we get into some of the injection stuff. So as Chris kind of talked about the architecture, Mojo applications are all JavaScript, HTML, and CSS. JavaScript can access different phone features through the dbus and doing various other things on certain privileges and that kind of stuff. So how do we, if it's JavaScript and it's HTML, how do we inject things? Well, obviously, we're hoping for places where they don't sanitize user-supplied input, right? So how do we do that? Well, we just basically would take a test string. Something that I like to do is, this is probably something you learned in your Web 101 class, how to do a meta refresh tag. This has pretty much taken out 6 or 7 bugs of Palm. This pretty much, using this string, we were really able to find like a bunch of bugs, and that shouldn't happen. So some of the injection vulnerabilities that we found, we'll talk about the contact list. The contact list was very interesting, such that if you were to take a vCard and it had HTML in it, it would then, if you viewed the contact or someone called you or whatever, it would execute HTML. And the question is, well, how terrible is that? What is the real consequence of executing HTML? In a lot of these, you couldn't execute JavaScript, but you could only execute HTML. Well, I can make your phone do a lot of funny things. So the application manager allows me to launch a movie player, or I can redirect you to a malicious website, or I can redirect you to a malicious website that has a vulnerability in, say like loads a doc file, and I know that doc file is malicious and can execute code. So there's a lot of things that we can do with the HTML injection. We'll get into another bug later that is JavaScript injection that is much more devastating, but these are pretty important. So the contact list was you download a vCard through Synergy, which is their way of like organizing all of your contact information, so you don't have 10,000, your dad's phone, your dad's voicemail, your dad's this, your dad's that. It would collapse everything and organize it into one contact. So they have Synergy. The calendar application, which we'll get into, our big bug is probably in the SMS or is in email. There's a couple things recent on SMS. Chris found a really cool bug in the updater. And the biggest problem outside of the email bugs are the notifications system. The notification system in this phone does not require user interaction. You receive an email, it has injection, it's executed. You got notified. There's nothing you can do to stop it. So this is a quick chart on the calendar and the email. So the calendar one is pretty simple. If you were to view the event, if someone, say you're at work, and somebody says, hey, listen, we got to get together and have a meeting. All right, well, they would send an email out and you get a meeting notice. Upon receiving the meeting notice, you would just have random execution of HTML. In this case, we're using meta refresh tag, which would just spawn another card with Google Link. If you were to get, say you had reminders set, so every 15 minutes before your meeting, you say, tell me, remind me, upon receiving the reminder notification, it's arbitrary execution of HTML. And then I talked about the notification system. So the email thing, we didn't break up the email and the calendar into their separate ones because it's kind of the same bug. It kind of fall from the same tree. If you were to receive an email where the to field had HTML in it, upon receiving that email without even looking at it, the notification would trigger and execute arbitrary HTML. So now you have all these different attacks that you could do with this thing.
Without user interaction.
Right, and the key there is a lot of this is without any user interaction. Like, before they fixed it, you couldn't stop it. One of the cool things is I used to mess with my boss by randomly send him stuff like at 3 in the morning, and he'd come in and be like, hey, I didn't go to that website. So it's kind of some fun things you could do, too. This is probably the biggest bug that we have. So this is the remote file access vulnerability that we disclosed. This was found, I think, 3 days before DEF CON last year. And I think it took a month or so to patch. What this bug is that we did some fuzzing with some JavaScript and HTML and so on stuff. And you had to watch it. It was very hard to fuzz automatically. But we did find that you could inject JavaScript. Okay, so the email systems is kind of privileged. So if I can inject JavaScript, what can I do while inside a privileged application? Well, it turns out we're not supposed to be able to access the backend system. It's supposed to be sandboxed in the backend system. So I shouldn't be able to get access to files. Well, there's a nice file URL handler that we can use. And the file URL handler is only allowed to be used in the privileged mode of privileged application. So what we do is we generate some JavaScript and basically go to this file, store the contents, and we steal anything off your phone we want. What's nice about this is Palm has stored everything in a single database. So all of your text messages, all of your contact lists, all of your emails, they're in a single SQLite database, single file.
Sorry to interrupt. We also need to make sure we get everything you're saying on the video tape. You need to use the microphone for that.
Sorry about that.
Oh, I didn't know that.
Yeah, you can pick it up and turn it around if you want.
Okay, I wander. I'm sorry.
Whatever works for you.
Well, I think we should show the demo.
Yeah, we'll show the demo now.
Yeah.
Hold on, let me step.
This is a video that Townsend made to do this. So
Hit F11. Scroll up because your screen's too small. We can't see it all. There we go. All right, so I'll try and talk a little bit louder to this over here. So basically, this is my exploit. This is the emulator. Why don't I do that? This is the emulator right here. This is a cookie catching website, which is basically I'm going to steal a file, throw it back to my website, and then I'll get an email upon receiving it. And this is just going to send me the malicious payload. So all this is, and what's going to be cool, is when you see it show up here, you're not going to see anything wrong with the email. It's going to look like a normal email. I apologize for the kiosk thing. This was not meant. Palm didn't believe me that this could happen, so I made this. So here's an email they received from me, the malicious guy. All you're going to do is have to click on it, and then I'm going to steal the files right off your phone. It's pretty much, what's cool here is you don't see anything. The only interaction is that you just have to click on it. You don't see the JavaScript here. There's your password file. So that was kind of pretty big bug for this platform because we didn't have to do memory corruption. We didn't have to remotely exploit it in a sense of shellcode and that kind of stuff. We just used JavaScript to pretty much own the phone. There is, and to show you how crazy of an exploit it is, this is the source code. Doesn't it look hard? This is all it took. So once we could execute JavaScript, we had a lot of capabilities. We could even access the Mojo framework and all the other stuff that we shouldn't have been able to do.
So that was just the raw HTML source of the email.
That's it.
yeah, and there's a distinction to make. Remember, I said that there's 2 web browsers.
Yeah.
The HTML app is running in Luna because it's a native application. So it's going to render in that trusted web browser. It's not the one you browse the web with. Now, I think that the file URI handler is but yeah. The problem is that there's 2 XML HTTP requests. One that was reviewed for use from the web, one that wasn't really reviewed for use